Case number 17. Let's verify or check this given identity. The ratio of tangent alpha and sine alpha is equal to secant alpha. To verify this identity, we need to examine the left-hand side and manipulate it in such a way that we could have an expression equivalent to our right-hand side, which is secant alpha. We are going to choose the left-hand side since it has more than one trigonometric identity. In cases where both sides will have complicated forms, we are going to express both sides in terms of either sine, cosine, or combination of both. But here, as mentioned, we are going to let the right-hand side as it is and use other processes that will allow us to come up with the equivalent secant alpha on our left-hand side. To do this, let us start with our left-hand side and express both of them, or just the numerator, in terms of sine or cosine or combination of both, because our denominator is already a sine alpha. Our tangent alpha is or can be written as the ratio of sine alpha over or we have here the ratio of sine alpha and cosine alpha. This is just the equivalent of tangent alpha, which is the numerator of our left hand side, and this would be equal to be divided by another sine alpha. Now from here we need to show that this is equal to the right hand side which is the secant alpha. And take note that whenever we are going to express an identity or verification of identity, we need to make sure that there are equalities. But since this has a lot of things to do, let us write it later. Okay, and simplify this first. Now, notice our numerator, which is originally tangent alpha, is now a rational expression expressed as sine alpha over cosine alpha. Our denominator is just sine alpha, or could also be written as sine alpha over 1. What's the purpose of this? Because when you have this form, you could see that you are just dividing two rational expressions, or in the simpler forms, you're dividing two fractions. Why fractions? Because you need to understand here that to divide rational expressions or fractions, you can use here the keep, change, flip method. The keep, change, flip method is a mnemonic technique in order for us to divide rational expressions or fractions. The keep stands for writing the numerator as it is. And we are going to take here the entire numerator earlier represented by tangent alpha. So this is the numerator here. Keep that. Instead of division, we change the operation into multiplication. And then we'll flip the denominator or the divisor. Hence, keep, change, and flip. When you flip, simply reciprocate it. Again, this is the keep, change, flip method. Keep the numerator, change the operation to multiplication, and then reciprocate or flip our denominator. Now, this should be equal to an expression equal to secant alpha. Now, let's simplify this. As we know, we are now multiplying instead of dividing rational expressions, and when we multiply them, we can use here the product of numerators over the product of denominators. Or, just for this, you can use here the cancellation law for multiplication, because the operation is now multiplication. We have here sine alpha. We also have here sine alpha, which means we have here 1 over cosine alpha, and this should be equal to secant alpha. Even if it's already done, the goal for verifying or checking identity is to make sure that both sides of the equation will have the same expression. So 1 over cosine alpha is actually our secant alpha, and this is equal to our original right hand side, which is also secant alpha. See that all the process we did reached here. Now we have verified this given identity, which means that tangent alpha over sine alpha is just equal to secant alpha. This case for missing identity is now closed. If you may, to be ready for some new cases, subscribe now.